Hi friends, we have studied in the previous lecture the hot weather season or the summer season. What we have studied in that is during the hot weather season, as the sun continues its northward journey, the temperature goes on increasing, and in the end the entire India comes under a hot wave conditions. But the hot wave conditions are severe in the north of India. Hot wave, hot weather means low pressure. That means the entire India is under the influence of a low pressure belt. So that is the pressure condition. But because the low pressure belt centers is the pressure gradient is not very developed, that means the difference in the pressure is not very high. Therefore, the winds are not that stronger. But as the sun continues its northward journey and the sun comes and settles on the Tropic of Cancer on the 21st of June, what we call it as a summer solstice, there is a transition from the hot weather season to hot weather season, that is the hot dry summers suddenly gets there is a sudden change to rainy summer season or to the southwest monsoon season or what we know as a rainy season. So this is a season, southwest monsoon season is a season from the month of June to the month of September. The month of September. It is season in India from the month of June to September is the southwest monsoon season. It is the southwest monsoon season. Now first understand what I am saying, doing it. Don't read anything, don't write down anything. I have given that most of the points here. If you feel that something is missing in the content which I will discuss after the telling you the concept of the southwest monsoon, then you can again re-refer the lecture and write down. But what are the most important things is written in the is already in the slideshow. Now let us understand what is the weather phenomena in the southwest monsoon. You understand the concept of a southwest monsoon. As I again tell you, don't go too much into the different theories of the southwest monsoon and understand the role of a low pressure belt, understand the role of a Tibetan plateau, understand the role of an ITCZ and understand the role of easterly jet stream. Have you noticed what I have said? I have said the role of the Tibetan plateau, the role of a low pressure center over India, the role of ITCZ and the role of easterly jet stream. Now what is this ITCZ? You apply your knowledge of climatology. What is an ITCZ? If these are the different pressure belts in the world, if there are different pressure belts in the world, ITCZ is what is the pressure belt which lies between 0 to 10 degree north and 0 to 10 degrees south. What is this? ITCZ is a low pressure belt or what we call as a belt of doldrums. Or we had studied that ITCZ is the thermal equator. What happens in this low pressure belt? From the region of the subtropical high pressure belt or the horse's latitude from the both the hemisphere, subtropical high pressure belt or the horse's latitude from both the hemisphere, wind originates and these winds are known as the trade winds. They come and they converge, they meet together, they converge at a belt which is known as belt of doldrums or the equatorial low pressure belt. Because there is a coming together of two different wind systems, of the trade winds from the northern hemisphere and the trade winds from the southern hemisphere, we call such belt as intertropical. Why intertropical? Because this belt is lying between the Tropic of Cancer and the Tropic of Capricorn. Convergence. Zone. Intertropical Convergence Zone or ITCZ. Now, what is this intertropical convergence zone? In this ITCZ, when the air comes from both the directions, the air will, after coming here, the air will then rise upwards. This why? Because the ITCZ is nothing but the thermal equator. Thermal equator means a thermal low pressure belt. The low pressure belt which is caused due to a heating of the earth. So it is known as a thermal equator. At the same time, we know that the neither of the pressure, any of the that means neither ITCZ nor the other pressure belts except for polar high pressure belt in both the hemisphere is stationary. No, none of the pressure belts are stationary. That means they continuously shift their direction along with the northward and the southward movement of the sun. They occupy their original position only during the period of equinoxes. That is during the spring equinox, 21st of March, and during the autumn equinox, that is 22nd of September. Why? Because during the equinoxes, the sun is exactly on the center, that is on the equator. So this is about the intertropical convergence zone. And now let us study why, how, and what is the role of ITCZ or intertropical convergence zone in Indian monsoon, and what important role it plays, that it is called as a monsoon trough. So what is a monsoon trough? Monsoon trough is nothing but an ITCZ. Very conceptual. So let us understand this process and let us enjoy this process of Indian monsoon. So we know that this Africa region, this is Africa, India, Thailand, Myanmar, etc. Then Australia, the equatorial belt, the Tropic of Cancer, and the Tropic of Capricorn. And Tropic of Capricorn, I have drawn the Australia just at the top, the Tropic of Capricorn. So obviously this is not to the scale, so the distance here is greater, but it is not the case. Don't do that in the examination. Make sure that, or why to leave it for the examination? I will draw it very properly here. So this is the 0-degree equator. This is 23.5 degree north. This is 23.5 south, and this is the 0-degree equator. Now let us understand what happens to the sun. We know in the summer season there is the Himalayan mountain system here. We know that in the summer season the sun is shifting to the north. So the position of the sun goes on continuously shifting to the north, and thus the Indian subcontinent starts getting heated. In fact, the entire northern hemisphere starts getting heated. This entire northern hemisphere there is a formation of an low pressure belt. There is a formation of a low pressure belt. But the low pressure belt is maximum, the low pressure belt is maximum in the northwest India. This is, we know that Therefore, there is a dominance of local winds during this position. But at the same time, there is an high pressure belt in the Australia region. There is an high pressure belt in this region. That is entire southern hemisphere mein there is an high pressure belt here. Now, this high pressure belt and the low pressure belt, with this concept, understand that the winds always move from high pressure to low pressure. Now, on the 21st of June, from the month of June onwards, the India starts getting heated up. Because the India starts getting heated, what happens is the ITCZ, that is the low pressure zone which is caused by the sun's heat, the thermal equator starts shifting northwards. And the presence of the thermal equator, when it starts shifting northwards due to the sun's heat, the entire ITCZ shifts northward, and the shift of the ITCZ is prominent over India. That is, the entire ITCZ, it shifts northward. So what is this ITCZ? ITCZ is the low pressure belt. With the shifting of the ITCZ northwards, before the ITCZ shifts northward, what was the upper air circulation in this region? The upper air circulation in this region was, there was the presence of two branches of a jet stream. If this was jet stream, one was the northern branch and the other was the southern branch. But remember, the ITCZ, because of its northward shifting on the Indian region, along the Himalayan region, due to high heating of India, due to large amount of heating of India, जहाँ पे temperature of around 45-50 degrees Celsius is common, the low pressure center is created. This we say that the ITCZ shifts, and because of the shifting of the ITCZ, the southerly branch of the subtropical westerly jet stream disappears, and this entire jet stream now shifts to the north. The subtropical westerly jet stream now shifts to the north. Why? Because the ITCZ occupies the Gangetic plains of India. So the ITCZ shifts to the north of India. Now, once the ITCZ shifts to the north of India, in the previous diagram, when I told you ITCZ, what is ITCZ? It is a convergence zone of two wind system, which the trade winds from both the hemisphere. Now, because of the shifting of ITCZ, obviously in this ITCZ, the wind has to come from both the hemispheres. That is, the southerly trade wind will be coming, and the trade winds from the northern hemisphere as well as the trade winds from the southern hemisphere will come. Now, an extreme low pressure zone is created all over India. This we already know, and therefore the winds originate from this high pressure zone and come towards this low pressure zone. Now, these winds originate and they get deflected to the left. So this is how the winds will originate. They come and first hit the Ethiopian highland region, giving rainfall to the Ethiopian highland region. But this winds earlier, they used to obviously go and meet into ITCZ. Now ITCZ is in the northern hemisphere. So this winds, after crossing the equator, the Coriolis force says that the winds will get deflected to the right, and therefore these winds come towards India, and they come towards the East Asia region, come towards India and the Southeast Asia region. Now you see, these winds are now blowing over an extremely hot ocean, that is the Indian Ocean. Because of high heat, because of high amount of insolation becomes hot, and when the ocean is hot, there is evaporation in the ocean, and these winds are blowing over the ocean, so they get moist. They pick up moisture from the ocean and they become moist and humid. And this moist winds are come to India as because of the change in the direction, these winds come to India as the southwest monsoon winds. These winds come to India as the southwest monsoon. Now, because of the presence of the Arakan Yoma mountains, you know that there is a Arakan mountain system of the Myanmar here. Because of the presence of the Arakan mountain system, these winds get deflected towards the Cherrapunji, towards the Bengal or towards the eastern coast of India, and they give very heavy rainfall to the eastern coast of India. While these winds also come and give rainfall to the entire Indian region. So what we have studied here, that there is a northward shifting of the ITCZ. The ITCZ occupies the Great Plains of region or the plain region of India. With the northward shifting of the ITCZ, the southerly branch of the subtropical westerly jet stream disappears. ITCZ is a convergence zone of the two trade winds. There is a low pressure over India and therefore the winds originate over the high pressure belt in the southern hemisphere, that is the trade winds of the southern hemisphere, after crossing the equator get deflected due to the right due to the Coriolis force and come to India as the southwest monsoon winds, So this is how the southwest monsoon wind is. But now let us magnify this area and study how the nature of the southwest monsoon in India is. How the nature of the southwest monsoon in India is. Now the southwest monsoon winds Myanmar, what is this? Western Ghats. What is this? Eastern Ghats. They together meet at the Nilgiris, Vindhyas, Satpuras and the Aravals. So the southwest monsoon winds, when they come to India, we bifurcate them into two branches. This is the way the southwest monsoon winds are coming to India. The southwest monsoon winds are coming to India. One branch in the Arabian Sea region is known as an Arabian Sea branch of the southwest monsoon winds, while the other branch of the Bay of Bengal region is known as the Bay of Bengal branch of the southwest monsoon winds. Now, the first branch to hit the mainland India is the Arabian Sea branch when the Kerala region gets the rainfall on the 1st of June. The Bay of Bengal branch, on other hand, see its direction. It goes parallel to the Tamil Nadu coastline. It goes parallel to the Tamil Nadu coastline and goes and hits the Bangladesh and the Myanmar region. Goes and hits the Bangladesh and the Myanmar region, giving very heavy rainfall in that region. But because of the presence of the high mountains, that is the Arakan mountain system of Myanmar, this Bay of Bengal branch is deflected towards India. This Bay of Bengal branch gets deflected towards India. This Bay of Bengal branch, after getting deflected towards India, what is further bifurcated into two directions. One gets attracted because towards the extreme low pressure on the northwest India and enters India. One gets attracted towards because the wind will get attracted towards the low pressure belt. So it gets attracted towards the extreme low pressure conditions of the northwest India. I will leave that here. But the other branch of the Bay of Bengal, you see there is a channeling effect, there is a funneling effect because of the Arakan Yoma mountains and the Indian peninsula, that the Bay of Bengal branch is funneled or channeled into a narrow region. It goes into the narrow region, gives rainfall to the Bangladesh. And what is this? Garo Khasi, Jaintia, Mikir, Rengma. These are the hills, out of which we did the Khasi hills is the highest. And therefore this Bay of Bengal branch goes and gives directly hits the Meghalaya plateau, giving very heavy rainfall to the to the Meghalaya region, or in the Garo Khasi Jalta Hills region, where Maswindram and Cherrapunji. Maswindram is the present day champion. Cherrapunji was the ex-champion. This champion means these two places record the highest annual rainfall anywhere in the world. This that it receives more than 200 centimeter of rainfall. This entire northeast India receive very heavy rainfall, more than 200 centimeters of rainfall. And because this area receives more than 200 centimeters of rainfall, the first thing, interrelation, that should come in your mind is that therefore the eastern Himalayas are densely forested. Therefore, the Tarai belt we have done in the east is wider than the west, while Bhabar, that means the dry region, is wider in the west. Now let us look at the the Arabian Sea branch. The Arabian Sea branch, see, some part of this Bay of Bengal branch goes to the Myanmar region, some part goes to the Thailand, some gives rainfall to the Bangladesh, while some part of this Bay of Bengal comes and hits India. That means the entire Bay of Bengal current is not coming and hitting India. Some part is coming and hitting India, while the entire Arabian Sea current is coming and hitting India. The entire Arabian Sea current is coming and hitting India. The Arabian Sea current comes and hits the western coast of India. The Arabian Sea current comes and hits the western coast of India. In the western coast of India, what is there? There is the Western Ghat region. There is a Western Ghat region. That is the Deccan Lava Plateau and the Western Ghat region. Why I am drawing this staircase? Because you know that it is a staircase-like feature on the eastern side. This is a Western Ghat region. So this is the west side, this is the eastern side. The Arabian Sea branch, full of moisture, comes and hits the Western Ghat region, and the air is forced to rise up along the Western Ghat region. As the air is forced to rise up, there is formation of the clouds and very heavy rainfall all along the western coast of India. So the entire western coast of India gets very heavy rainfall. Again, more than 200 centimeters of average annual rainfall. The western coast of India gets more than 200 centimeters of average annual rainfall. Now, but on other hand, after crossing the Western Ghats, after rising here in the Western Ghat region, the rainfall will start decreasing. Why the rainfall is start decreasing? Because on the leeward side of the Western Ghat, this is a windward side. The other side is an leeward side. Because on the leeward side of the Western Ghat, the air starts descending. And you know from climatology that when the air starts descending, then the amount of precipitation, amount of rainfall decreases, because the air is heated adiabatically. जब heat होती है air, then its moisture holding capacity increases. When its moisture holding capacity increases, it won't give rainfall. And therefore, Mumbai, which is located on the western side of the Western Ghat, and Pune, which is located on the eastern side in the Ghat region, though the distance is very near geographically, what is the kilometer between Mumbai and Pune? 190 kilometers, but the difference in the rainfall is very high. Mumbai receives average annual rainfall of around 200 centimeters or around 250 centimeters of average annual rainfall, while Pune records just 50 centimeters of average annual rainfall. Why? Because Pune is on the leeward side of the Western Ghat region. Therefore, the, the amount of rainfall goes on the leeward side of the Western Ghat region, and on any leeward side of the mountain, the rainfall decreases. So in the UPSC, the question if this they ask you which two cities in India will have maximum difference of rainfall. If the option is Mumbai and Pune, if the other option is Calcutta and Allahabad, third option can be Allahabad and Delhi or Allahabad and Varanasi, fourth option can be anything. Remember, the answer is Mumbai, Pune receives, there is a maximum difference in the amount of rainfall. Why? Because one city is on the windward side of the Western Ghat, while the other city is on the leeward side of the Western Ghat. The other city lies on the leeward side of the Western Ghat. Other city lies on the leeward side of the Western Ghat. Similarly, instead of Mumbai, Pune, they can give you an option of Mangalore, or they can give an option of Bangalore. And Bangalore. These two cities will also record maximum difference in the amount of rainfall. Mangalore and Bangalore will also record maximum difference in the amount of rainfall. So Mumbai, Pune, Bangalore, Bangalore. So keep it in mind if such question comes that the maximum difference in rainfall. And again I am saying solve the past year questions because you will get an idea of how the questions is asked by UPSC. Start solving both prelims as well as mains. But start solving at least a preliminary question because obviously the mains is also important because unless you write, cracking mains is difficult. Unless you solve multiple choice questions, MCQs, cracking prelims is going to be difficult. Now, not only this, as the temperature, as the air starts descending, the amount of rainfall will start decreasing, and therefore this belt of India, that is the red color belt, that is in this region, I am drawing this region, this narrow belt of India, which runs parallel to the Western Ghat, is the drought prone region of India. It is the drought prone region of India. It is a drought prone region of India. Example is the Marathwada region of Maharashtra. Example is the northern part of Karnataka. Example is the southern part of Madhya Pradesh. But majorly the drought is in the Latur Usmanabad district of Maharashtra. Or uska continuation is also the Vidarbha region of Maharashtra, the Yavatmal district, the districts which have experienced maximum amount of farmer suicide because lack of irrigation facilities plus dependent on monsoon. So the drought prone. So the amount of rainfall goes on decreasing to the by the Arabian Sea branch. The amount of rainfall goes on decreasing from west towards the east. So the Arabian Sea branch will go here and the amount of rainfall will go on decreasing. It will get less and less rainfall. So I am not drawing it by blue color. Now, the other Arabian Sea branch, there is a second stream of Arabian Sea branch which passes through the Vindhyas and Satpura region and gives heavy rainfall to the central part of India. That is the Dandakaranya Plateau region, Chhattisgarh, even the Nagpur region of Maharashtra. Why it is having good amount of forest? Because the second branch of the Arabian Sea enters the Rift Valley, which is formed by the Vindhyas and the Satpuras and give rainfall to the central part of India. The third branch of the Arabian Sea, you see, goes parallel to the Aravallis. Why it goes parallel to the Aravallis? Because the direction of the Aravalli is such that the Aravallis do not act as an effective barrier. For the mountain to be acting as a barrier, it should lie across the direction of the winds. We have done that in the geomorphology. so that it can act as a barrier that it will stop the rainfall and the air will rise upward. But the Aravallis are parallel to the direction of the monsoon winds, and therefore the monsoon winds bypass it. Obviously, Mount Abu region, that is the hill region here, will get rainfall. So the third branch of the Arabian Sea goes parallel to the Aravallis and comes and hits the Himalayas, and therefore it gives very heavy rainfall all along the foothills of the Himalayas, That is the Tarai region of India. There is a consequences of floods here, flash floods he comes here, Kedarnath disaster, if it's Uttarakhand disaster, if it was in the recent memory, one of the most dangerous natural disaster because of so you can understand why the heavy rainfall in this region, because the Arabian Sea branch will go and meet and go and give rainfall along the foothills of the Himalayas. Not only this, the both Bay of Bengal branch and the Arabian Sea branch meet near Agra, and after that they continue its northward journey and give rainfall to the rest of India. But as the Arabian Sea branch is going inside, or as the Arabian Sea branch is going inside, or the Bay of Bengal branch is going inside, is there a source of water or is there a source of moisture from the winds? The source of moisture from the winds should come from the large water bodies such as sea or ocean. Geographically, river is not such a large water body that it can supply moisture to the winds. And because there is no supply of moisture to the winds, the amount of rainfall goes on decreasing in this region. And therefore, this region is the semi-desert region of India. That is, Delhi gets very less rainfall. Punjab and Haryana still get very less rainfall. Therefore, these are the semi-arid regions of India. While because of the presence of the Aravallis, because of the way the Aravallis are, Rajasthan is consequently a desert because Aravallis lie in the direction parallel to the direction of the monsoon winds. On the other hand, because the Coromandel coast lies in the parallel direction to the Bay of Bengal branch, this Coromandel coast is also dry. Why it is lying in the, you see the shape of the Indian coastline is that it lies parallel to the Bay of Bengal branch. On the other hand, the Coromandel coast, that is the Tamil Nadu region, lies on the rain shadow part of the Arabian Sea branch. So the Tamil Nadu region is dry during the southwest monsoon season. When the entire India gets rainfall, the Tamil Nadu region is extremely dry region during this monsoon season. Not only this, you see, still the monsoon has not covered major part of India. This region is without rainfall. This region has no major rainfall. How it is done? Now, you see, this area is the Tibetan Plateau region. The Tibetan Plateau region is at a greater height as compared to the surrounding lands. Around 4,000 meters to 5,000 meters is an average height of the Tibetan Plateau. This is the Tibetan Plateau. It is one of the highest plateaus in the world. Now, because it is high of a greater height, it receives high amount of insolation as compared to the surrounding regions. It receives high amount of insolation. Because it receives high amount of insolation, the air over the Tibetan Plateau becomes very, very hot and a low pressure develops over the Tibetan Plateau region. This low pressure develops over the Tibetan Plateau region and the air rises upwards. There is a presence of a jet stream, subtropical jet stream over the Tibetan Plateau region. Just one branch, that is the northerly branch. It flows. This air, because of the extreme height of the Tibetan Plateau region, gets heated and rises upwards. After the air rises upwards, that is, the air will start rising upwards because of high heat of the Tibetan plateau. After rising upwards, there will be an anticyclonic circulation. That is, upper there will be an anticyclonic circulation. That means a circulation in the form of anticyclonic circulation develops over the Tibetan plateau region. This anticyclonic circulation you can see here means it is going away from the center. This anticyclonic circulation or high heating of the Tibetan plateau region causes the air to rise up. One part goes towards the equator, the other part goes towards the polar regions. We are not concerned about the polar regions, we are concerned about the equatorial regions. Let me use a different color here. The equatorial part of the Tibetan plateau, of the air which rises of the Tibetan plateau, goes in the upper atmosphere. After going, it will start going towards the equator. So suppose this is an air which is rising upwards because of the heating of the Tibetan plateau. One part will go to the north, the other part will come towards the equator. While this air is coming towards the equator, it is in the which hemisphere? Northern or southern hemisphere? It is in the northern hemisphere. The Coriolis force says that the air will get deflected to the right. So this upper air circulation, I am not doing it at the ground, I am lifting it upwards from here. Or if you are not getting it, I will use something different color. This air from here, after getting heated, it gets lifted upwards. So this air from here is getting lifted upwards. It is traveling towards the equatorial region. It is coming towards the equatorial region. But because of the Coriolis force, it is getting deflected to the right in the upper atmosphere. So in the upper atmosphere, this deflected air to the right comes over India as an subtropical easterly jet stream. Subtropical easterly jet stream. So during the winters, there was a westerly jet stream, but during the southwest monsoon season, there is an subtropical easterly jet stream. There is a subtropical easterly jet stream. And what is the importance of the subtropical easterly jet stream? This subtropical easterly jet stream drives the monsoon bearing cyclonic winds or monsoon bearing winds into rest of India, and thus the entire India becomes blue in color. That means the entire India will get rainfall. The entire India will get rainfall. Only thing is, the some parts of India get very heavy rainfall, that is the Western Ghat region, and the Northeast India get very heavy rainfall. Some parts of India get little rainfall, except that there is one part of India which gets no rainfall at all, that is the Coromandel coast region. Remember, I will give you why it does not get rainfall. The Tamil Nadu coastline does not get rainfall, and because of the direction of the Aravallis, the western, because this also will get rainfall, the western part of Rajasthan is a desert region. So such is the phenomena of Indian monsoon. Again, let me repeat what we have studied. We have studied that during the monsoon, ITCZ shifts to the north. We have studied due to the shifting of the ITCZ, the winds come as the southwest monsoon winds. The southwest monsoon winds has the Arabian Sea branch and the Bay of Bengal branch. Arabian Sea branch where it gives rainfall, where the Bay of Bengal branch. The only difference is the entire Arabian Sea branch comes and hits India, while some of the Bay of Bengal branch goes to the Thailand, goes to the Myanmar region, goes to Bangladesh, while some comes and hits India. The Arabian Sea branch goes parallel to the Aravallis, therefore the Rajasthan is the desert. The Bay of Bengal branch goes parallel to the eastern coast near the Tamil Nadu, and therefore the Tamil Nadu region does not get rainfall during the southwest monsoon. But we have seen that this region gets rainfall during the northeast monsoon. What about this? Is about the surface winds. What about the upper air circulation? Upper air circulation in the upper air circulation, that is the jet streams during the monsoon, there is a presence of two jet streams. There is a presence of an subtropical westerly jet which lies to the north of the Himalaya. Subtropical westerly jet which lies to the north of the Himalayas. It blows from west towards the east. It blows from west towards the east over the Tibetan plateau, while there is on India there is an subtropical easterly jet stream. That is why in the chapters of jet stream in climatology, I said that India is a special country because all over the world the jet streams are only from west to east, except that there is a one jet stream, that is easterly jet stream, which flows over India, but only during the monsoon season. Why? Because this is developed because the southern branch of the subtropical westerly jet stream disappears. Why does it disappear? This disappears because of the northward shifting of ITCZ, and therefore this ITCZ, the shifting of the ITCZ is the one of the main reasons for the monsoon in India, and therefore the ITCZ is known as monsoon trough. If the ITCZ does not shift, then the low pressure is not created, and if the low pressure is not created, then this southern hemisphere here got trade winds which originate over Australia won't cross the equator and come to India as the southwest monsoon season. Now, unlike now, now you remember whenever the monsoon comes, it comes suddenly in the daytime, in the night, or in the night time, whatever in the month of June or July, wherever which part of India you live, the the sky will become overcast and it will rain heavily along with lightning and thunder. This phenomena of the is known as the burst of monsoon. Monsoon comes with, as I say, band baja barat, or it comes with burst. This phenomena is known as the burst of Indian monsoon. So this is the technicality of an Indian monsoon. This is the conceptual part of an Indian monsoon. Do you understand the importance of ITCZ, monsoon trough? Do you understand the importance of the Tibetan plateau? High heating of the Tibetan plateau results into air rising upwards. This air then goes in the upper atmosphere, air rises upwards. One branch of this air comes to India as an easterly jet stream, and this easterly jet stream plays a very important role in the Indian monsoon. So that is the importance of the Tibetan plateau region also. So in the winter season, subtropical westerly jet stream, northern branch and southern branch. But during the rainy season, subtropical westerly jet stream to the north of the Himalayas, as well as easterly jet stream to the south of the Himalayas. So let us look now into detail what that should be the content in your answer. Let us look at what to write here. Now let me rub this board first so that the slides are clear. What to write here is, see, during the month of April and May, when the sun shines vertically over the Tropic of Cancer, a large landmass in the north of Indian Ocean gets intensely heated. This causes the formation of intense low pressure in the northwestern part of the subcontinent. These conditions help in the northward shift of the position of ITCZ. So this is what we have studied. The intertropical convergence zone is what? It is a low pressure zone located at the equator where the trade winds converge, and so it is a zone where the air tends to ascend. In July, the ITCZ is located between 20 to 25 degree north latitudes over the Gangetic Plain. The ITCZ, let me do it again. The ITCZ is also known as a monsoon trough. So what is a monsoon trough? It is an ITCZ, is also known as a monsoon trough. Now come to the next. Due to the shift of the ITCZ, the trade winds of the southern hemisphere cross the equator between 40 to 60 degrees longitude. You don't have to write so much in detail, and start blowing from the southwest to northeast due to the Coriolis force. This, the flow, we know that wind ka name is given from the origin where it blows, and therefore this becomes the southwest monsoon winds. Become the southwest monsoon wind. So you can see this dark blue line, ITCZ, it is going straight, but because of the intense hitting of the Tibetan plateau, its prominent shift, that of the blue line, is over the Indian subcontinent. Nowhere in the world the shift is so prominent, but in the Indian subcontinent region the shifting is extremely prominent. So you can see here this the trade winds of the southern hemisphere, the trade winds of the southern hemisphere is the trade winds of the southern hemisphere between the across the equator, and they become the southwest monsoon winds. So if the question comes that the southwest monsoon winds are what? These are the trade winds of the southern hemisphere itself. These are the trade winds of the southern hemisphere. We'll come to the next slide. But at the same time, what I did not do in the winter season, what is the northeast monsoon, or what is the rainy season in Australia? In Australia, similar to what ITCZ shifts because of the shifting of the sun in the northern hemisphere, similarly, the ITCZ will shift southwards because of the shifting of the sun in the southern hemisphere. This southward shift, when the sun is in the southern hemisphere, the northern hemisphere, including India, will experience a winter season. And during the winter season, we know that the northeast monsoon winds will originate. So in the winter, the ITCZ moves southwards, and therefore the reversal of winds from northeast to south and the southwest takes place. These are known as the northeast monsoon. So you can see in the diagram, December and January ITCZ is over Australia. Therefore, the North Australia, this entire North Australia, where Darwin is the major city, gets the monsoon rainfall. But during June and July, that is the summer season, the ITCZ is over the northern part of India, and therefore this come to India as the southwest monsoon, while this originate in India as the northeast monsoon, They originate over India as the northeast monsoon winds. The the shift here, don't go by just by the direction of the arrows. It will be this way, and then it will be shifting this way. So winter season, remember, during our winter, ITCZ is over Australia. ITCZ is over Australia. Now, or you can better get an idea from this. See the ITCZ during July, the dark blue line is over India. The ITCZ, this should be the 0 degree should be the normal position of the ITCZ, but the due to physiography, due to different relief, due to the high heat of the Tibetan plateau, due to extreme heating of the India, the ITCZ shifts most prominently over the Asian region in the July, and then it shifts towards the Australian region during the month of January. That is, the northern part of Australia gets the monsoon type of a climate. Now, let me go to the next slide. Now, this is also what we have done. Due to the shifting of an ITCZ, the southern branch of the westerly jet stream disappears and its place is taken up by the easterly jet stream. Which was the easterly jet stream? The jet stream which I drew in the previous diagram. That is, this jet stream is known as an easterly jet stream. This jet stream is known as an easterly jet stream. Whose place does it take? It takes the place of a southern branch of an westerly jet stream. Thus, the upper air circulation, that is, upper air circulation means the jet stream circulation, is reversed during the monsoon. The easterly jet stream flows in the upper air during the monsoon, and this easterly jet stream is responsible for driving the rain-bearing vortices into India. Why I am saying the upper air circulation is reversed during the monsoon? Because during the winter season, that is the non-monsoon month over India, during the winter season, that is during the northeast monsoon, there is a presence of the subtropical westerly jet का southern branch and subtropical easterly westerly jet का northern branch. But during the monsoon summer season, that is the diagram above is of the summer, there is an easterly jet stream. But during the winter season, during the summer season, there is an easterly jet stream, but during the winter season, there is an westerly jet stream. Now, what is this? Due to the easterly jet stream, this results into this driving up of the rain-bearing winds or the cyclonic vortices in India, results into more active southwest monsoon and heavy rainfall is caused. Thus, the easterly jet is important for southwest monsoon in India. One unrelated question is I am asking, what is this westerly jet important for which rainfall in India? This westerly jets, just revise your, try to remember, this is responsible for western disturbances in India. This western disturbances are what? Winter rainfall in India. Winter rainfall in India. Now, what is the role of a Tibetan plateau? This can be a separate question for the mains. That is, explain the role of a Tibetan plateau. Explain the role of a Tibetan plateau. Now, the Tibetan plateau is a very vast area having average height of 4,000 meters. Due to the high height of the Tibetan plateau, it receives more amount of insolation. I have covered this point. Due to intense heating, an upper level anticyclone develops in the Tibetan plateau. That is, the air from the Tibetan plateau rises upwards and it goes in the anticyclonic manner. On the southern side of this upper level anticyclone, that is India ka side, the southern side of this upper level anticyclone, the direction of the wind flow is from west to east. This east blowing upper air anticyclone is known as easterly jet. If you are again getting confused, that is due to the high heating of the Tibetan plateau and upper level anticyclone, not at the ground level. an upper level anticyclone develops. That means such an anticyclone in the upper atmosphere develops, and this results into this upper level anticyclone is nothing but an easterly jet stream which comes to India. That is the southerly branch of this upper level anticyclone. So thus, in fact, the recent observations, this you can use in the climate change also, has revealed that the intensity and the duration of heating of the Tibetan plateau has the direct bearing on the amount of rainfall in the Indian monsoons. When the summer temperature of air over the Tibetan plateau remains high for sufficiently long time, it helps in the strengthening of the easterly jet and results in heavy rainfall in India. So why? Because I've already told you that the easterly jet stream is more important for rainfall in India. So when there is very high amount of heating of the Tibetan plateau, the easterly jet stream is strong, and thus the rainfall in India is very high. So note down this point. This point is very important. Thus the Tibetan plateau plays an important role in the Indian monsoon. Now the southwest monsoon comes over India. The southwest monsoon first comes over India in Kerala. That is, we are talking of the mainland India. We are not talking of the Andaman and Nicobar Island. Now this is the date you should remember. It covers the Kerala coast by 1st of June and then swiftly reaches to Mumbai between 10th June. By mid-July, the southwest monsoon engulfs or comes over the entire subcontinent. So you can see on the 1st June, what is this line? These are the lines which join the places of equal rainfall. This on the 1st June, this entire part will get rainfall. 5th June, then 10th June in Mumbai, and by 15th July it will cover the entire India. Thus the entire India gets rainfall. Remember, mainland India में 1st June Kerala. वैसे Andaman Nicobar you can see it will come in the month of May itself. In the month of May itself. Thus we can predict how the amount of monsoon, whether it will be good monsoon, whether it will be bad monsoon, by predicting the rainfall in Andaman and Nicobar, or even by studying about the heating of the Tibetan plateau region, and also by the El Nino. Why? Because during the El Nino years, what you have to remember for the Indian monsoon, El Nino years. Is more or less is drought in India. Or a deficient monsoon in India. What is El Nino? We have done in oceanography. El Nino is warm current in the South Pacific. So high amount of warming of the South Pacific results into drought in India. Why high amount of warming? Because high amount of warming of the South Pacific creates a low pressure belt in the Australia in the South Pacific region. Air can never flow from low pressure to low pressure. There has to be a high pressure belt here and the low pressure belt here in India for the rainfall to occur. Then the rain in the southwest monsoon season becomes abruptly. As the result of the first rain, it brings down the temperature substantially. This is fine. The sudden onset of the moisture-laden winds associated with violent thunder and lightning is known as the burst of the monsoon. It is also known as a break, but don't remember break because it is given in the NCERT, so I have added it here. I have tried to use as much language of NCERT as possible because monsoon is an important topic. So it is known as a burst of the monsoon. So what is the burst of the monsoon? The sudden onset of the rainfall. The monsoon approaches the landmass in two branches. That is the Arabian Sea branch and the Bay of Bengal branch. This is also we have studied. Now you can see this is the Arabian Sea branch of the Indian monsoon. This is the Bay of Bengal branch of the Indian monsoon. The Arabian Sea branch will come and hit the Western Ghat region. This is the Western Ghat. Give very heavy rainfall to this part. Therefore, iska application you see. Western Ghat therefore has been declared as a biodiversity hotspot. The Western Ghat therefore is a World Heritage Site. Again repeating, biodiversity hotspot by which body? WWF, Conservation International, UNESCO. It is by Conservation International. And World Heritage Site by which body? By UNESCO. The Bay of Bengal branch, you see the coast of the Tamil, shape of this Coromandel coast in Tamil Nadu is such that the Bay of Bengal branch goes parallel to it. And then comes to India. Now you can see one branch will go parallel to hit the Myanmar, but there is an Arakan Yoma mountain system, so it will be concentrated in the Bangladesh and the northeast India. There is a presence of Garo Khasi Jaintia hills here. This entire area will get very heavy rainfall. Just see areas I am marking of very heavy rainfall. Why I am marking this? You will see in the soil, these are the areas of laterite soil. You will see in the vegetation, these are the areas of biodiversity hotspot in India. And you will see generally environment ecology, though it is not, I am not teaching here environment ecology. You will see that these are the areas where questions will come. National parks in these areas. That generally question won't come from the national park in UP or Rajasthan. National park, endemism, species diversity, biodiversity, this high five words, these are related to the Annamalai National Park, Nilgiri Thar, lion-tailed macaw, Himalayan musk deer, or we can say red panda in India, or flying squirrel in India. This in the biodiversity rich regions of India. The second branch of the Indian monsoon, as I told you, passes between Vindhyas and the Arabian monsoon passes between Vindhyas and the Satpuras, and this region will get rainfall. So Madhya Pradesh, Chhattisgarh region, no doubt Madhya Pradesh is the vast state, receives rainfall. So highest forest area in India is of Madhya Pradesh by total amount of forest. Which is the highest forest area in India? Madhya Pradesh. Now you see the rainfall is not as high because it is not directly coming from ocean and giving the rainfall. It is passing through the trough. Trough में भी थोड़ा rainfall होगा. So the rainfall is decreased, and therefore यहाँ पे the forest will be deciduous forest. यहाँ पे on the other hand Western Ghat and the Northeast India, it will be an evergreen forest region. The third branch of the Arabian Sea goes parallel to the Aravalli ranges and gives rainfall along the foothills of the Himalayas. You see it when it goes swiftly, there is a too much difference between this low pressure and the surrounding low pressure. That means obviously when these winds come very swiftly, when there is a strong monsoon, unfortunately we can see an Uttarakhand disaster happens because the rain goes very swiftly. Kedarnath, Badrinath, cloudburst and the flash floods happen during this season. The Arabian Sea branch, on other hand, mixes with the Bay of Bengal branch near Agra here. You can see the two arrows are mixing and then it moves to the Punjab, Haryana, Chhattisgarh region. But as it is going here, it is passing over the land, so it does not get fresh moisture and therefore the rainfall goes on decreasing. So this is the now, the Arabian Sea branch is larger than the Bay of Bengal branch. This is what you remember. The Arabian Sea branch is larger than the Bay of Bengal branch. I've already done the entire Arabian Sea branch advances towards India, whereas only a part of the Bay of Bengal branch current enters India. The remainder of it proceeds to Myanmar, Thailand and Malaysia. Now, the Arabian Sea branch is divided into three distinct streams. The first stream strikes the west coast of India, gives very heavy rainfall of over 250 centimeters on the west coast of India. It strikes the Western Ghats, and what is the kind of rainfall? Western Ghat is a kind of an orographic rainfall, that is the mountain induced rainfall. But on the leeward side, that is what I told you in the diagram, on the leeward side of the Western Ghats, the amount of rainfall will go on decreasing on the leeward side of the Western Ghats. So Mumbai will have maximum rainfall and Pune the amount of rainfall goes on decreasing. As you go down, Marathwada region, the amount of rainfall goes on decreasing. Vidarbha ka western part, less rainfall. Telangana, less rainfall. So I'm just asking you, I'm not here, just this is a food for thought for you. Is the demand for separate states in India, that is Telangana was demanded, it has been considered by the government. But now there is also demand for separate Vidarbha. Backwardness of Marathwada region. Is the demand for separate states in India somewhat related to the amount of rainfall? Because the pursued backwardness or the backwardness of an area, is it because of lack of irrigation facilities in India? It is because of the farming crisis in India, and the farming crisis is related to rainfall. Rainfall is related to the orography. So can you see the link here? Use it somewhere in your essay, etc. But the leeward side, so coming back here, but on the leeward side, the rainfall is drastically reduced, about 30 to 50 centimeter. Therefore, a drought-prone area parallel to the Western Ghat is due to the rain shadow effect of the Western Ghat. Note this. Why there is a drought-prone area parallel to the Western Ghat? I have already told you which drought-prone area. It is due to the rain shadow effect of the Western Ghat. The second stream enters the Narmada Tapi Trough and reaches central India. The third stream moves parallel to Aravalli without causing much rainfall. Why? Because the Aravalli is because of its shape, because Aravalli does not act as an effective barrier. Act as an effective barrier. Therefore, consequently, the whole of Rajasthan is a desert area. So you can see that this is the average annual rainfall map of India. Darker the region, darker the blue color means very heavy rainfall. So you see the Western Ghat region, western side of the Western Ghat region receives very heavy rainfall. The entire Northeast India receives very heavy rainfall. There are pockets of rainfall in central India, heavy rainfall. But you can see the light color region, western extremity of Rajasthan, that is the Marusthali or the Thar desert region. No rainfall. Or the entire Rajasthan, because this is how the Aravallis are, does not get rainfall. And you can see this drought prone area, light color area, which I am shading in Maharashtra and Karnataka, North Karnataka. Maximum number of farmer suicide occur from this region. This region is in the news because if there is a drought here in India, there is a serious problem of drinking water. So why is this? This is because the rain shadow effect of the Western Ghats. Because the Western Ghats are right here. The rain shadow effect of the Western Ghats. So here you are getting prelims ka 2 answers. The next is the Bay of Bengal branch is divided into two distinct streams. Bay of Bengal branch is divided into two distinct streams. One branch strikes the coast of Myanmar, part of southeast Bangladesh, but the Arakan hills along the coast of Myanmar deflect this towards India. So you can see the Arakan hills in Myanmar also play an important role in the Indian monsoon because they deflect the Bay of Bengal branch in India. Now, therefore it enters the West Bengal and Bangladesh from south and southeast. Now this branch splits under the influence of the Himalayas and the thermal low in the northwest India. So there is a thermal low pressure belt in the northwest India. So this branch moves westwards along the Ganga plains reaching as far as Punjab plains. So this is what I have shown in the map. So you can see here how the branch is moving towards the Bay of Bengal region. The other branch moves up the Brahmaputra valley and the northeast, causing widespread rainfall. This strikes the Garo Khasi Jaintia hills of Meghalaya, and there's Masundram and Cherrapunji located in the southern slopes of which hills? Garo, Khasi or Jaintia? This can be the question in UPSC, and you should remember in the Khasi hills record very high rainfall. So the Masundram and Cherrapunji are located below the Khasi hills in Meghalaya. Below the Khasi hills in Meghalaya. So this branch goes here and gives very heavy rainfall in the Garo Khasi Jaintia hill region. Masundram records. The Masundram is the place which is having the world record for highest rainfall, and then it is the Cherrapunji region. Now, why Tamil Nadu is dry during the southwest monsoon? I have seen many notes. Generally, the notes give only one reason, that the Tamil Nadu coastline is situated parallel to the Bay of Bengal branch of the southwest monsoon. This is just one of the reasons. Second reason is also that it lies in the rain shadow area of the Arabian Sea branch of the southwest monsoon. So the two reasons here. So you can see here, it lies in the rain shadow region of the West Bengal, while यहाँ पे it lies in the parallel region. This is the average annual rainfall map. This is not the map of only southwest monsoon. इसलिए Tamil Nadu is also showing blue. But if we see the rainfall of the southwest monsoon, this entire region will be dry. Now, what is the break in the southwest monsoon? Sometimes there is no rainfall at all, or sometimes there is no rainfall for 7 days, 15 days, etc. So, during the southwest monsoon period, after having few days of rainfall, if the rain fails to occur for 1 or more weeks, for how many? 1 or more weeks, it is known as a break in the monsoon. Why? This can be because of the change in the position of ITCZ. The ITCZ position does not remain constant. It changes its position. For rainfall to occur, the ITCZ has to be at a proper position. But with the change in the position of the rainfall, the low pressure zone is shifted, that is the monsoon trough is shifted, and the break occurs. So the reason can be, one reason, that the axis of the trough lies at the foothills of the Himalayas during the break period. So you remember, if the ITCZ lies exactly at the foothills of the Himalayas and not on the Gangetic plain, there will be break in the monsoon. Second, due to in the North India also, the rains are likely to fail, that is the break will occur if the rain bearing storms are not very frequent along the monsoon trough or ITCZ over this region. That means there is no low pressure zone in the Bay of Bengal, therefore easterly jet stream cannot drive it. So ITCZ. But the third reason, this is not the second reason, the third reason, that is on the western coast of India, that is this western coast of India, if sometimes the winds flow parallel to the western coast of India, then even the western Ghats do not act as a barrier, and therefore there will be no rainfall. That is what the third point is. Over the western coast, the dry spells are associated when the winds blow parallel to the coastline. So this is the break in the monsoon. So when the axis or the ITCZ lies along the foothills of the Himalayas, if there are no cyclonic storms or there is no moist bearing wind, and when the air blows parallel to the western coastline. So this is all about the Indian monsoon. Do revise it again if you look at the diagrams here, and we will meet for the retreating monsoon. All the very best. Enjoy your studies. Thank you very much.